Hello everyone! Raise your hand if you like listening to music. I know I do, but I've been wondering, what do you think music looks like? Today, we're going to use a tool called the Chladni Plate to see the effects of sound. And then, we're going to make our own version. As we know, sound travels in waves through solids, liquids, and gases. But this wasn't always common knowledge. Ernst Chladni was an 18th century German scientist, sometimes referred to as the father of acoustics, who showed that sound travels via waves by creating a way to visualize the effects of sound. He did this by sprinkling sand on a metal plate and then drawing a bow across the edge. This caused the plate to resonate. The sound waves would interact on the plate, causing patterns to appear in the sand. When multiple sound waves of the same frequency pass through the same medium, they sometimes collide. This interference creates a pattern called a standing wave. In every standing wave, there are points along the medium that appear to be standing still, called nodes. On the plate, this is where the sand would tend to gather, as it would be still at those points. The points in the standing wave where the most movement or displacement occurs are called the antinodes. On the plate, we would see this as the areas without sand, as the sand bounces away from the vibrating surface. During his research, Chladni drew many illustrations of the various patterns he had observed, which are now referred to as Chladni figures. Understanding these principles of resonance became very important to instrument builders in creating violins, guitars, and other instruments in maximizing the beauty of their sound. The same principle that we see in the Chladni plate can be observed in other materials as well. For instance, you can also see the effect of standing waves in water. If you don't have a Chladni plate, you can experiment using your voice and a large drum. By matching the note at which the drum is tuned, you may be able to watch the sympathetic vibrations of the drum head displace grains of salt. We tried this in our Sound Discoveries class. However, we do have a Chladni plate today, so let's see it in action. Here's our square metal plate, and over here we have a frequency generator which produces sound waves. Down below we have a mechanical driver which pulses the plate at a rate corresponding to the frequency. And then over here we have some fine sand. This dial on the frequency generator controls the frequency or pitch of the sound. You can think of it as changing the various notes. This dial controls the amplitude or size of the sound wave. You can think of it as changing the intensity of the sound. Since we already have an idea of what we may see as we change the frequencies, let's observe at which frequencies we begin to notice distinct patterns. Please have a piece of paper and a pen or pencil ready so that you can jot down the number you see here when a pattern appears. I'm going to start by sweeping through the entire range of frequencies this generator can produce, which goes up to 400 Hertz. Whenever you notice a pattern, please write down the corresponding frequency you see here. Afterwards, we'll revisit some of these and take a closer look at our patterns. What did you see? Did you notice any patterns in the sand? What did you think about what you observed? I definitely noticed some patterns, and I wrote down a few frequencies I'd like to look at more closely. The first major change I noticed was at 50 hertz. I didn't see a pattern per se, but this is where I began to see movement. Then, as the frequency rose towards 60 hertz, the sand moved into a circle. By 80 hertz, the circle had hollowed out. If you can, draw a little diagram of what this pattern looks like. Next, we'll dial through all the way to 230 hertz. What does this shape look like to you? Please take a moment to draw this pattern. At 240 hertz, it changes again, almost resembling a tic-tac-toe shape. Can you draw this pattern? Finally, we'll cycle up to 400 hertz. This shape reminds me of a flower or a butterfly. Go ahead and sketch this pattern as well. Let's compare some photos of these frequencies and see if we notice anything. If you thought the patterns grew more complex as the frequency went up, you were right. Frequency, also known as pitch, is the number of times per second that a sound pressure wave repeats itself. These are measured in hertz. Humans can generally hear sounds between 20 and 20,000 hertz. Frequencies above 20,000 hertz are known as ultrasound, whereas frequencies below 20 hertz are referred to as infrasound. Back to our Chladni plate. As the frequency increases, there are more points of interference between the sound waves, which creates more complex patterns. Here's a DIY project you can try on your own. You can create your own simple version of the Chladni plate with a few household items. All you need is a Bluetooth speaker, a bowl that is slightly larger than the speaker, a cover for the bowl, a device with a tone generator app, and some table salt. Putting this together is really easy. The first thing you'll want to do is download a tone generator app to your device. I'm using one called Sonic, but if you search for tone generator app, you'll find many free options. Now we're ready to build our homemade Chladni plate. Step 1. Make sure your speaker and your device are connected to one another and both at their full volume. Step 2. Place your speaker in the bowl with the speaker side facing up. Step 3. Carefully stretch your bowl cover over the bowl, keeping it as taut as possible. The flatter your surface, the more easily you'll be able to see your patterns. I'm using this bowl cover, but if you can't find these, then you could also cut and stretch a large balloon and secure it with electrical tape or a rubber band. Step 4. Sprinkle some salt on top of the bowl cover. Now you're ready to test your homemade Chladni plate. I'll demonstrate first by pressing play on my app and then changing the frequency. Here we go. Now, it's your turn. Explore what happens with the salt when you change the frequency on your app. When you're finished, write down your observations. Later, you can share the results with your class. Thank you for joining me today in seeing the effects of sound through the Chladni plate and then learning how to make your own. I'm Miss Liz from the Cincinnati Symphony Orchestra Sound Discoveries program. See you soon!